We're going to look at fraction multiplication and the standard algorithm for computing a product. To begin with, let's recall the fraction addition standard algorithm and then compare it to the fraction multiplication algorithm and see where people sometimes make mistakes. With fraction addition, we had to have a common denominator and then add the numerators. In this video, we're going to be examining the product of 1/3 times 2/5, but I want to step back and look at the sum of those two numbers. So 1/3 plus 2/5. We need to find a common denominator, which is 15. Becomes 5/15 plus 6/15. 11/15 is our answer. With fraction multiplication, no common denominator is needed. Instead, we multiply the numerators and multiply the denominators, so we multiply straight across. If we look at 1/3 times 2/5, this becomes 1 times 2, multiply the numerators, 3 times 5, multiply the denominators, or 2/15. So the first place where I see people get off track, it's not that it's wrong, it's that it's needlessly difficult. What they do is they find a common denominator and then multiply. So the needlessly difficult version of this is 1/3 times 2/5. Find the common denominator, 5/15 times 6/15, like in addition, and then they take 5 times 6, 15 times 15, and get 30 over 225, and then are left with the task of simplifying. So that was a whole lot of work when all we needed to do was multiply across. What I've also seen students do, which is wrong, it's not just that it gives you more work, it's that it's incorrect, is take 1/3 times 2/5 and get in addition mode. So they look at 5/15 times 6/15, and then they multiply the numerators and keep the denominator to get it at 30 over 15, which is 2, which is the wrong answer. So in the addition mode, but that doesn't work for multiplication. So what we want to do is we want to actually look at why this algorithm that we use here makes sense. Our process is going to be to visually represent the fraction multiplication and then examine the solution and compare it to the algorithm and see how it makes sense to us. So 1/3 times 2/5 can be interpreted as 1/3 of 2/5 of a unit. We would start a visual representation of this by starting with the unit. So here's 1 unit. And then we would work from right to left. We're going to take 2/5 of the unit. So we divide our unit into 5 equal parts here. And then we select 2 of those. So we end up with 2/5 of a unit. Then we come along and we look at our 1/3 of the 2/5 of the unit. So this becomes our intermediate whole here. We ignore this white region and we just look at the 2/5 and we say we need to take 1/3 of this. 1/3 of the 2/5. There's our thirds. This is 1/3. 1/3 of the 2/5. Right here, we take the 1/3 of the 2/5, and that is our final shaded region within the whole unit. So our answer is 2/15. When we look at this, we can think of the 2 in terms of an array. It's a 1 by 2 array. And we can think of the partition of the whole unit as not as 15, but as a 3 by 5 array of rectangles. And this fits into our algorithm. So here we have our 1/3 times 2/5. We multiply the numerators. We get that 1 by 2 array that we can see right here. We multiply the denominators and we can get the 3 by 5 array that we saw for the unit whole. So the numerator, recall, is the count of the shaded parts, which we can see in the 1 by 2 array, and the denominator is the partition of the whole, which we can see as the 3 by 5 array of rectangles that we've created. Now, some people like to think of their fraction multiplication not as 1/3 of 2/5 of a unit, but instead as a length times width area perspective here. So if we did that, we would end up with 1/3 of a unit for our length, 2/3 of a unit for our width. Here is our 1/3 if this whole vertical side is our length. And then here is our 2/5 of a unit if this whole horizontal side is our width. So here we would shade in the 2/5, shade in the 1/3, see the overlapping region, and again we'll have a 1 by 2 array, and our whole will be partitioned into a 3 by 5 array, giving us 2/15 as the answer.